Hello, friends. Today we're getting into lesson 9, which involves the distance formula in geometry. Some of this is going to start to feel like algebra. We're like, oh, we're back on a graph. But the thing is, a graph, like an XY coordinate, is just a really useful way of being able to measure things, talk about particular locations. Instead of being vague about this thing is over there to the left of the table, whatever it might be. If we have a grid, then we can be exact about where it is we want to be. And so we're going to learn to work with that. And we're going to come back to it from time to time in geometry as we learn different formulas and theorems, etc. So let's start just by considering a simple example. If we have these points here on this number line, so again, an XY graph is just two number lines put together. That's it. So let's start with just a single number line. And what we find is, so we want to know what is the distance between, and then 2 points, like in this case, U and G. So if I'm looking at that, here's U. Let me do this in red so it shows up over there. U and G. So that's a distance of 2. How can we show that um, arithmetically? You could say, well, 3 minus 1 gives us 2. Also, if we say negative 1, sorry, 1 minus 3, that gives us negative 2. But if we take the absolute value, then we get 2. So then it wouldn't matter which order we put it in. If we're taking the absolute value, the distance, we always want to end up with a positive distance. We can't have a distance that's negative. We can have negative position. We can have negative direction. And we do that in physics with quantities called vectors. But we're not dealing with that here. We're just looking at a distance, which is going to be a positive number of some kind. Okay, and then how about the difference between M and D? So here's M and here's D. Okay, so that's -4 minus -1. And so that's going to be -4 plus 1. So if we take the absolute value, then we get 3. And that makes sense. You can see it from looking at it. But we're looking to see what is it that we're doing arithmetically, algebraically to get that answer, because we might not be able to count it at some point. And what about between T and O? Right, so the difference between T and O, that is an O, it looks like a triangle. That distance, we're going from -2 to 2, so we expect it to be 4, if we can kind of count it. But let's see. So or let's say 2 minus -2. Arithmetically, how does that work out? Well, that's like 2 plus 2, right? Minus a negative, same thing as adding. And that gives us 4, which is what we expect to get. Okay. So what are we doing? We're taking those 2 points, those 2 coordinates, and we're subtracting them in order to get that distance. Works well when it's one-dimensional. But what about if we've got 2 dimensions? I want to go back to the last lesson, like something like this here. So between G and M, what is the distance? Uh-oh, it's at an angle. So how do we handle this? Here's what we do. First, we look at the horizontal distance. Okay, so the horizontal distance is from here to here. And then the vertical distance, which is from here to here. If we look carefully at that, we realize, hey, that's a right triangle. So if we take the horizontal and the vertical distances, then we can always find that other distance by using the Pythagorean theorem. And that's what we're going to do here. So let's, using the same method we did before. So the vertical distance, they have coordinates of 2 and -1. So the vertical, d vertical is 2 minus -1, which in this case is 3. Okay. And then d horizontal, I'm writing that as a subscript to indicate that's the horizontal distance, is going to be 1 minus -3. And I'm putting it in that order on purpose because I know that it's going to work out to be positive. But we are taking the absolute value of these, if that's of concern. If you're taking the absolute value, the order doesn't matter. You could do -3 minus 1 gives you -4. Absolute value gives you 4. So how does the Pythagorean theorem work now? Well, the overall distance squared equals the vertical distance squared plus the horizontal distance squared. And we have those distances here, as you can see. And so d squared is going to be the square root of 3 squared plus 4 squared. Now you might realize this is a 3, 4, 5 right triangle. And so, uh, I'm going to get 5 here. Oh, I forgot. I've got d squared. I just want d because I took the square root. So d is the square root of 3 squared plus 4 squared. Now, how does this play out? So, I mean, this is going to be d equals the square root of 3 squared is 9, 4 squared is 16. You add them together, you get 25, which is 5. Okay. Now, uh, you can do this separately. You can do it as finding the vertical, finding the horizontal, and then doing the Pythagorean theorem. But we could just put everything into one big equation. What we can do is we can have this and this, and we can put them directly into here. So what does it look like when we do that? The square root of the difference of those verticals squared plus the difference of the horizontals squared. You put it all together, and this is what you get, the distance formula. Okay. And so it's, believe it or not, it's a little minus sign in there. I end up having to rewrite some of this stuff. But it's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Here I have it flipped. This is the horizontal, and this is the vertical. And again, so it's just the horizontal distance squared, the vertical distance squared. Add them together, take the square root, and that gives you the distance. We are using the Pythagorean theorem to do that. You can memorize this. Like I have students who just memorize the distance formula, which is fine. But notice what I did in the lesson. I worked up to it through the one-dimensional, the two-dimensional, using the one-dimensional and the two-dimensional, and then getting up to this formula. It's really best if you understood it. So you could get to like a test or a quiz or something and say you forgot the distance formula, but you should be able to reason through it and kind of figure it out, knowing the Pythagorean theorem and how to find the distance between 2 points on a graph. Always strive for understanding over memorization. Right? Memorization is not bad, but memorization undergirded by and coupled with understanding is really the best thing to do. Thanks for watching. Don't forget to like and subscribe.